Welcome to Unit 5, Lesson 1. In this lesson, we're going to learn about the graphs of exponential functions. Hopefully you know a little bit about what exponential functions are, but let me give you a quick overview if you do not. Exponential functions are functions that increase rapidly. They take your previous value and they multiply by a constant amount each time. So for example, maybe you start with the number 3. So when x is 0, y is 3. And you multiply each previous value by 2. That might look something like this. You have 3 here, and then you take that 3, multiply it by 2, you get 6. Multiply that 6 by 2, you get 12. Multiply that 12 by 2, you get 24. But the key thing is that same number is being multiplied to get to the next number. So you could figure out the fourth one by just taking that 24 and multiplying it by 2. So that'd be 48. And you could go backwards. You could say -1. Instead of multiplying by 2, you could say divide by 2, because that's working the other way. So that'd be 1.5. So that's the idea. Constant multiply to get to the next problem, to get to the next part. An easier way to write this function, your starting amount being basically your y-intercept in this case. When x equals 0, that's going to be the first number you pick. And then each time you multiply by 2, that's your base. So your base is going to be 2. We call this 3 the a value, a times b, and then we raise it to the x power. And the x power just means how many times you're multiplying it to get to a certain point in the function. So a times b to the x power. So the generic form is y equals a parentheses b raised to the x power, where a is the starting amount and b is the base. So looking at that number, your starting value 3, your constant multiple, your base, what does that look like on a graph? Well, it's going to look like a growth. You do y equals 3 times 2 to the x power. It's got this curve, and it starts off really flat, because when you're in small numbers, it doesn't do much to increase it. But once you get to the positive values, it skyrockets. So when you double something, it increases very quickly. So exponential growth is going to look just like that. The y-intercept you can get by clicking on the y-axis on Desmos, or if you have your own graphing calculator, you could find that. You can see right here it's at 3 when x equals 0. When that number that you're multiplying by, the number in the base, is greater than 1, we consider that to be growth. If it's between 0 and 1, it's decay. So take a look at this problem here. Let's say your starting amount is 64, and you're multiplying by 1/4. Well, 64 times 1/4 is the same thing as 64 divided by 4. Well, that's getting smaller. That's 16, and then 16 divided by 4 is going to be 4, and 4 divided by 4 is going to be 1. So each time you increase, it's going to decrease in value, and that's a decay. So that's going to look like this. So if you said y equals 64 parentheses 1/4 or 0.25 raised to the x power, you can see here it's decreasing as it goes to the right. So it starts off very sharply. In fact, it's going to cross the y-axis at 64, because that's your y-intercept, that's your starting value, and then it basically gets cut in half, cut by a quarter each time, and it decreases, but it never, of course, is going to go below 0, because if you divide by 4, you just get closer and closer to 0, but you don't actually get below 0. So that's going to be decay. And that base there is between 0 and 1. So, you know, any decimal like 0.25, 0.5, 1/2, 1/3, 2/3, numbers like that is going to decrease, and it's going to go down as it goes to the right.